So we will be continuing today's, So we will be continuing the topic that we have covered, okay, in last class, right? So if you remember, we were covering which topic? We were covering this topic, right, of energy. We discussed what is potential energy, what is kinetic energy, right? And we kind of discussed the interconversion of energy. Yes or no? Tell me, yes or no? Yes, right? I hope all of you remember. Yes. Okay, so we will discuss more about that. We'll discuss how energy is related with each other. What is the conservation of energy? What is the equation, right? Okay, and then we will try to solve some problem based on that. Now, before starting, let's try to have a small recall test. Let's see how many of you can remember the concepts. Okay, so tell me, what is the answer of question 1? Tell me, kinetic energy is the... Yes, very good. Easy, right? This is easy. Very good. Kinetic energy of a body having mass m and velocity v is very good. The answer is A, half mv square. Very good, everyone. Okay. Second one. When object A works on object B, object B dash energy. Tell me, gain or loss? I hope all of you remember this. Very good, Prahlad. Very good, Chandan. Very good. Right? Puneet, very good. Prajwal, very good. Right, Prajwal? Yes, gain, right? Because when you're doing work, right, the energy is gained. Yes or no? Yes, very good, Navya. Very good, Puneet. Third one, an object of mass m starts from rest and attain a final velocity. Okay, that's a very nice home, Yashash, in your background. I thought that it is your real
Sir, background,
home.
sir.
But I saw you a couple of days back in Vidyanagar itself, and I don't think that any house is like that in Vidyanagar. It is a duplex kind of home, right? Okay. So third, what is the answer of third? An object of mass m starts from rest and attain final velocity. What is the net change in kinetic energy of an object? Tell me. Start from rest and attain final velocity. Net change in kinetic energy. Think about it. Okay, Yashash? Fourth one, we will discuss this. We'll discuss question number fourth. Tell me what's the answer fourth? B. Okay, everyone. What will be the change in kinetic energy of an object when its velocity is doubled? Right? Yes, that is easy. Yes, very good, Prajwal. Very good, Yashash. Prahlad, correct. Nandini, correct. Okay. Yes, so the answer is B. Very good. Last one, fifth one. The kinetic energy of an object, decrease with increase in its speed. False or true? Obviously it is false, right? Yes, very good. Right, so let's see. So the answer, I hope all of you gave the correct answer. Yes, very good. Wait, I'll just mess in the group. Most of you haven't joined yet. See, I've told you, right, that this physics class only one day we'll have from 5 to 6, one day. Okay, it will be their loss. Now, we will start with what we have left. So I hope all of you remember this equation. All of you remember this equation. Okay, right? Kinetic energy, potential energy, and all those things. So when you talk about conservation of energy, the topic, wait, it is recording, right? So when you talk about conservation of energy, okay, the main expression, I can say, okay, energy can neither be created nor be destroyed. Means if anything is happening, so one form of energy is converting into other form of energy, right? So what should be the expression? Now the expression is something like this. I hope all of you remember conservative force and non-conservative force. Yes or no? Yes or no? Right? Yes, that's what I'm explaining. Okay. So when you talk about total energy, I write it like this: work done by conservative plus work done by non-conservative force, means total work done, right? Whenever we are doing any work, right? Total work done plus heat energy or whatever energy we have should be equal to change in kinetic energy. Okay, change in kinetic energy. So this is the expression. This is the fundamental expression of conservation of energy. Got it? Right? Got it? So if I ask you, okay, what is the fundamental expression of this energy? The fundamental expression is total work done plus total heat energy should be equal to change in kinetic energy. Got it, Prahlad? Got it? Yes? Everyone got it? No, it is bracket. It is not I. Okay. Now, whenever we talk about our syllabus, our syllabus is associated with only conservative work done, right? So this is equation one. This is equation one. This is right. It has A. Okay. Like total work done plus heat should give me total change in kinetic energy. But obviously we don't have to use this, but this is the general equation, right? The most general one. Okay. And we know that, I hope all of you remember, work done by conservative force is negative of change in potential energy. Yes or no? Tell me, yes or no? How many of you remember this from last class? That work done in conservative force is equal to negative of, right? Yes, Tapish, Vaishnavi, very good. Everyone remember? Okay. Now, our syllabus is very easy. Our syllabus is very easy. We don't have to worry about non-conservative force. We don't have to worry about heat also. Okay. So we will assume that there's no non-conservative force. So work done by non-conservative and Q, both is zero. Both will be zero. Got it? Right? In our syllabus, in class 10th, sorry, in class 9th. Very good, Tapish. So if this and this both is zero, think about it. If this is also zero and this is also zero, what can I say? Tell me, what can I say? Right? Can I say that, okay, we have work done by conservative should be equal to change in kinetic energy? Yes or no? Yashash, tell me. Yes? Right? Okay. Now, I'll use this expression B. Now using A and B, can I say, okay, this is work done by conservative, this is minus delta U. So I'll write minus delta U is equal to delta K. Yes or no? Tell me, yes or no? Means if potential energy is used, then kinetic energy will be increased. Now this might seem confusing. Okay, this might seem confusing for some, right? Yes. Okay. So I can say, what is delta U? We know that delta U is U final minus U initial. Okay. And delta K is K final minus K initial. Right? Change. Delta is change, which is always final minus initial. Okay. Which is always final minus initial. Yes. Very good. Very good. So put the values over here. So it will be minus U final minus U initial is equal to K final minus K initial, right? Got it, everyone? Tell me, got it? Yes? Now let's try to rearrange it. Let's try to rearrange it. It is U, by the way, it is not V. My handwriting is horrible. Let's try to rearrange it. So we will get what? U final plus U initial is equal to K final minus K initial, which will again transpose, right? After transposing, I'll get K initial plus U initial is equal to K final plus U final. Yes or no? Tell me, yes or no? Yes or no? Tell me. Right? Yes. So this is the expression, this is the that we have to use. This is in our syllabus. Got it? Tell me, got it? This expression is in our syllabus, right? Yes. No, it is like conservation of momentum, but it is your conservation of energy. So I can say that initial energy kinetic plus potential energy is equal to final kinetic plus potential energy. Yes or no? Tell me yes or no. Anyone have any issue in this? Got it? Anyone have any issue in this? Yes or no? Raise your hand. If you got this, raise your hand. Or if anyone have any doubt, please ask. What is the meaning of D is equal to 0? D. What is D, Prahlad? Where we have D? Prahlad, what is D? See, delta 0. See again, delta means change. This is delta, which is change. Okay, which is, if you are talking about delta any parameter, which means delta S. So delta S is S final minus S initial. Yes.
So I was talking about D is equal to 0, which is written after we assume that.
We assume that, okay, this is not D, this is Q. Sorry, my bad. This is my bad handwriting. Okay. This is Q, heat. So I'm assuming that there is no friction force or no non-conservative force, and there's no heat also. Heat is not there. Okay. Got it? Got it? Yes or no? Tell me, yes or no?
So,
Anyways, yes?
so here we are taking work done by conservative force as delta U. So why are we taking that? Because delta K means we've took that from that expression, but why are we taking delta U?
See, again, if you remember last class, we derived now what is the definition of potential energy, right? If you think the definition of potential energy, right? The very definition of potential energy was, it is work done by conservative force. Yes or no? Tell me, in bringing one object from one point to the point. Got it? I spent one whole class, the last class was this only, right? I hope all of you remember this. Yes or no? Tell me. I gave the example of money and food, right? If you spend money, you'll buy food. So in the same way, if work is being done, then it will consume your potential energy, right? So from there we derive that change in potential energy is negative work done by conservative force. Got it? Clear? Clear now? Yes?
Yes,
Okay. So this is what you have to remember. Simple, right? If you don't remember anything else, just remember this. Initial energy is equal to final energy. Okay? Got it? Right? Now, think about it. Let's try to solve one example. Okay, let's try to solve one example. I hope all of you understood this concept. Yes or no? Tell me. Now, if I have to write this, so I can write like this. Okay, half initial kinetic energy is m v1 square plus initial potential energy is mg h1 is equal to final potential energy, final kinetic energy is half m v2 square plus final potential energy is mg h2. Anyone have any issue in this? Tell me, anyone have any issue in this? Think about it. This formula, anyone have any issue in this formula? Shrishti is here. Shrishti is here. Shrishti SR, not Shrishti SM. Shrishti SR is not here. She is absent, right? Shashank, Satvik, Sanchit.
That's Satvik here.
Okay. Everyone is getting this concept? Yes, Haley, Chandan.
Yes, sir.
Okay, very good.
Yes, sir.
Okay, very good. So let's try to imagine, right? Because see, again, if you understand a concept, you should try to form any problem, okay, right? By yourself. Try to find, yes, try to find, yes, Shakib, I'll repeat, don't worry, I'll repeat. Okay, no issues. Now try to think a situation, The most common situation is like this. Suppose, try to imagine the situation. try to imagine the situation. Okay, suppose Yashash is on his cycle, right? Forget about cycle, right? Yashash is here on his cycle, okay, and this height, okay, wait, okay, so this height is suppose 10. This height is 10, okay? Got it? Think about it, yes or no, right? And suppose mass of Yashash is 50 kg, suppose 50 kg, right? If I ask you, if he just, yes, start from here, think about it. It starts from here with zero velocity, right? From here, he just starts with zero velocity. So what is the velocity at this point? Tell me, what is the velocity at this point? This is the problem, okay? Right? Yashash, 75 kg, seriously? What you are doing?
73, sir.
What you're doing in lockdown? Okay, and here I was thinking that I was the only one who was gaining weight. Anyways, so see, I hope all of you understood this problem. Yes or no? Tell me. I hope all of you understood this problem. Yes? Okay, so let's try to think. Okay, kinetic energy initial. What is the initial kinetic energy? Tell me. Initial kinetic energy is half m v1 square. Now we know that v1 is equal to 0. v1 is equal to 0. h1 is equal to 10. h2 is equal to 0. Yeah, your voice is cracking. Okay, so it's better message. And V2 is V that we have to find. This is the information that is given. And mass is given as 50 kg. Now, even if mass is not given, it's fine, right? Mass will be cancelled anyways. So V1 is 0, so it will be 0 step by step. Now, potential energy initial. Everyone just focus here step by step. Potential energy initial is what? mgh1, right? Okay, now m I'll not put. Okay, so mg into h1 is 10 into 10. Okay, or if you put every value, so it will be 50 into 10 into 10. I'll take g as 10. G is equal to 10. Okay, 10. So this is equal to what? 5,000 joules, right? Now, next, kinetic energy final. Kinetic energy final is equal to what? Half m v square, we don't know, and potential energy final is equal to what? Height is 0, no? Height is 0, so it will be 0. Got it? Tell me, got it? Anyone have any doubt till this point? Anyone have any doubt till this point? Tell me.
Sir,
No?
height is 10 meter, na sir?
No, see, initial height. At this point, what is the height? At this point, final, because it is final potential energy. Na? So when you talk about height, you have to see initial and final. So finally, if Yashash is coming over here, right? Think he slided through this wedge, roller coaster, and he came here. So what is the height now? 0, na? Got it?
Yes.
Okay. So now write the formula, which is initial kinetic energy initial plus potential energy initial is equal to kinetic energy final plus potential energy final. Got it? So kinetic energy initial 0 plus potential energy initial is mg h1 is equal to kinetic energy final is half mv square plus potential energy final is 0. Now put the value. So mgh1 is 5,000. We have already calculated. This is half into 50 into v square. Got it? Can you calculate v square? V square will be equal to 2 into 5,000 divided by 50. 100 times. Right? So v is equal to 10 root 2. 10 root 2 meter per second. Yes or no? Tell me yes or no. Yes or no? Shakib, you understood this? Yashila, correct? Shakib, got it now? Tell me. Sanchit, Abhiramya, Sai Purvi, Manoj, Jayati, Prajwal. Easy, Avya, Brayad, Radhika, Shreya. Okay, very good. So this is one problem. Okay. Yes, we will discuss more problems. Okay. Still, Yashash, again, think about it. We are talking about conservative force. Yes or no? Tell me. Right? Even if you slide, if you directly go down, still the velocity will be same, na? Because conservative force means Navya, if it is deleted, we will just talk about concepts which is important to us. Okay, we won't be discussing much theory. Okay, and we'll focus more on this chapter. Okay, got it, Navya? Right? That's why I'm giving you more time in this chapter, because this chapter is more important. Right? This sound will not come in your school exam, right? Tell me, yes or no? Will sound come in your exam, school exam? Navya?
No, sir.
No, right? So what I'll do is I'll focus more on this chapter as well as the first chapter, which is motion, because those two chapters are very important, plus force. Prahlad, definition of kinetic energy, that was not the definition of kinetic energy. Okay, the definition of kinetic energy is basic, the energy by the virtue of motion of any object, right? If any object is moving, right? If any object is moving, then the energy associated with that is your kinetic energy. Got it? Tell me, got it? Yes? Okay, so let's talk about one more case, one more very fundamental case. Now think about it. I'll give you one case. Okay, think about it. How many of you know about pendulum? Tell me, how many of you know about pendulum? I hope everyone know about pendulum, right? Yes or no? Everyone know about pendulum? Yes, very good.
Yes, sir.
Okay. Now suppose I'm having a pendulum like this. Suppose this is a pendulum. Okay. Now I can say that, okay, this pendulum, this is the mean position of the pendulum. Yes or no? This is called your mean position, right? This is your mean position. Now, if you keep your pendulum like this, think about it. If you keep your pendulum like this, okay, and like this, right? Got it, right? Now, what are these position called? Tell me. Try to understand this concept. This is very interesting. This position, this position, this position, right? Guys, if you can turn on your camera, it will be better. Okay, I can like see you guys and like it will be better for me. Okay, so what is this position called? This position is called as extreme position. Extreme position. And this is called as mean position. Mean position. Now, this is the example of energy conservation. How many of you have played using this? Tell me. How many of you have actually seen this? Raise your hand. You can just tie a stone in a like thread and you can do it, right? Okay. So let's think about it. When you talk about this, I'll just write it as position A. Okay. Position A, position B, position B, and position C. Okay. So suppose you keep a pendulum and at position A, you just like suppose this is your pendulum, right? And you do it like this, okay, and then leave it, okay, right? Then leave it. What do you think? What happens? What will happen? Tell me, right? Okay, I'm not having a pendulum. I'll just use this, right? Suppose this is a pendulum. Suppose this is a pendulum here. From this point, I'll just see what will happen. Yes or no? Tell me. I hope all of you observe this, right? It will oscillate, yes or no? So this is the phenomenon of oscillation, but what is happening on the energy level, right? So if I ask you, okay, what is the energy at point A? At point A, what is the energy? Tell me. What is the, and suppose this height is h. This height is h. So what do you think? At this position, at point A, right? What is the potential energy? At point A, what is potential energy? Tell me. Mass is m. Mass is m. Think about it. Yes, very good, Yashila. Very good, Puneet. It is mgh. And what is kinetic energy? What is kinetic energy? What is kinetic energy? Tell me, what is kinetic energy? Zero. Yes, very good, right? Okay, so this will be zero. So at point A, at this extreme position, potential energy is maximum, kinetic energy is minimum, which is zero. Now at point B, think about it, at point B, right? The height is zero. So I can say, okay, potential energy will become zero now, and kinetic energy, think about it. What will happen to kinetic energy? What will happen to kinetic energy? It will become maximum, which is half mv squared. Yes or no? Tell me, yes or no? Right? Got it? Anyone have any doubt? Anyone have any doubt till this point? Tell me. Sanchit, Mansa, Aditya, Tanish, Melissa, Meghna, anyone have any doubt? Clear? Right? Very good. Now at point C, what will happen at point C? Tell me, what will happen at point C? Just try to imagine what will happen. No, Prahlad, see, na, see, right? That's why I showed you, right? Think about it. Suppose this is your pendulum, right? This is your pendulum, okay? Now, from this point, I'm dropping it. So is it at rest at point B? Tell me, is it at rest at this point? No, na? Right? Because when you talk about this potential energy, right? Yes, very good. It will become same as A. So in this case, potential energy will be mgh and kinetic energy will be 0. Anyone have any doubt in this? Anyone have any doubt in this? Tell me. Anyone have any doubt in this? No? Is it easy now? Is it easy now? Everyone got this concept? So can I say that, okay, in case of pendulum, the potential energy and kinetic energy, sum of potential energy and kinetic energy is always, tell me, constant, right? Yes or no? So this is also example of conservation of energy. Makes sense? Tell me, makes sense? Right, everyone? Okay. Okay. Shall we solve one more problem? Shall we solve one more interesting problem? Tell me. One more interesting problem? Yes? Okay. Let's try to solve one more interesting problem. Let's see. Okay. I'll make it. Sorry, guys. I don't know why this happened. Okay. Okay. Yeah. Suppose I'm taking this case. Let's see how many of you can solve it, right? Let's see how many of you actually understood the concept. Okay. Let's think. This is a conceptual problem, right? Now suppose, right? Okay, suppose this Zilan is like a biker, right? And he want to do a stunt, right, Zilan? Right? You want to do a stunt. Okay, so Zilan want to do this stunt, right? He want to be like an awesome biker who do all kind of stunts. Okay, So the stunt he is doing. No. Then who want to do the stunt? Prahlad will say no. Yashash is all. You don't know any stunt. No issues, right? I'll teach you physics. Then you can do the stunt. So suppose he's on his bike, right? Forget about, like, this is a bike. He is on his bike, right? He's on his bike. Okay, and the stunt is this. He needs to reach at this point, right? He needs to reach at this point. Got it? That is the stunt. So Martha is saying that no bone will be left, right? No. Physics. Okay, physics. So my question is, and the radius of this is a circle, right? And the radius of the circle is 10 centimeter. 10 centimeter. Okay, got it? Right? Now my question is, how fast, right, he should ride a bike? How fast he should ride a bike so that he can just reach at this position? Now this is a very interesting question. Very interesting question. Okay. Yes, it is a perfect semicircle. It is a perfect semicircle. Let's try to understand this. Okay. Topmost position, point A. This is point A. He needs to reach at point A. Okay, he needs to reach
The
at point.
radius 10 centimeter है कि 10 meter है?
Okay, sorry. 10 meter, my bad. 10 meter is very big, right? Sorry, I'll just give you 1 meter. 1 meter. Okay, 10 big is very, or 2 meter. Let it be 2 meter. Radius 2 meter. Okay, got it? My question is, how fast he should drive the bike so that he can reach at this point, point A. Okay, got
Sir,
it?
what is the mass of that bike and
Mass will be cancelled, na? Think about it. Mass will be cancelled, right? Anyways, mass, if you want to take mass will be 50, but mass will be cancelled. Yes or no? Tell me. Right? So you need to worry about mass actually. Think about it. Think about it. This is a very interesting question, right? Think. He just need to reach at this point A. Chandan, you got it? You got this problem? Everyone think about this problem, okay? Okay, everyone. So I hope all of you, yes, all of you have tried this. Okay. Tapish, your roll number was there only. Okay. You could have seen your roll number, right? Now let's see, guys. Now think about it, right? Think about it. I want to find the velocity, okay, at this point, right? At this point B. So I can say that, okay, let's suppose point B, at B, potential energy is 0. Yes or no? Potential energy is 0. What about kinetic energy? Kinetic energy is half mv square. That we need to find. Yes or no? Tell me, yes or no? Yes or no? Right? See how good problem this is. How good this is. Okay, this is a beauty. This problem is a beauty, right? Let's see why it is a beauty. So at point B, at point A, this is what you would have done. At point A, right, you would have done like this. Potential energy is equal to mg into 2r. Yes or no? Tell me. Yes or no? Think about it. Yes or no? Yes. Raise your hand. Yes. And kinetic energy, you guys have made kinetic energy is equal to 0, right? Think about it. Yes or no? This is what you did. This is what you did. You made kinetic energy is equal to 0. Yes or no? This is what you did and equated it. Now, if I say that this is wrong, then Now your question is why it is wrong? Because you don't want him to break his bones, right? You don't want him to break his bones now, right? If he want to be at this point, right, then he need not to fall down. Yes or no? Tell me, think about it. Think about it. Yes or no? If his kinetic energy would be zero, then he will fall down, na? Because there will be mg in downward direction. Think about it. I'm using the concept of second chapter, right? Got it? Yes or no? How many of you agree with me? If the kinetic energy will be zero, right, then there is only one force in downward direction, right? Got it? One force in downward direction, and this will fall down. Okay, sorry guys, from next time, I'll just remove this permission, okay, to enter, so you can enter, okay. Yeah, we are neglecting friction over here, obviously. Now think about it. Suppose, right, he need not to fall down at this point. So what should be, right, what should be the concept that we have to apply over here? Think about it. Think about it. At this point A, right, if he reached at point A, if we talk about this force which is the downward direction, so he will fall down, no? He will fall down. But obviously he need not to fall down, right? He should not fall down. So can I say, okay, this force should be balanced by this force in upward direction? Yes or no? Tell me, yes or no? Yes or no? And what is this force? What is this force? Which force will be there in upward direction? Tell me, what is this force called? I hope all of you remember. What is this force called? No, if anything is moving in circle, right, then this force is called as centrifugal force. You don't know this, kya? Centrifugal force, centrifugal.
Sir, we can't determine it in this case, no, sir, because we don't know whether it is going towards radius or it going away from the radius, no, sir. Then how can we determine it is centrifugal or centripetal?
Right? If it is upward, then it is centrifugal. Centripetal is this gravity, right? Okay. Centrifugal and centripetal are just the term given to the force toward the center and away from the center, right? So suppose center is here. Which force is toward the center? Mg. So centripetal is mg and centrifugal is this. And the formula of this force is mv square by r. Got it? Tell me. Got it? Right? The formula of centrifugal force is given by mv square by r. Did you know this? Yes or no? Tell me. Did you know this? Yes or no? You know this? No. Now think about it. Now think about it, right? Suppose, I hope all of you have seen this death wall in circus. Yes or no? Or in TV? Sorry, on TV. How many of you like seen that? The death wall where biker just not in Mario, right? He just, yes, ride his bike on the wall. What do you think? What is the reason that he's not falling down? Right? I want him to do the same stunt. Okay, so this is the force which will, yes, right, death well. Okay, so here at point B, kinetic energy should not be zero. Kinetic energy should not be zero. Kinetic energy should be this. Okay, right? This is very important, very interesting concept. Most of you might not be getting it very easily, right? So please ask. Okay, please ask. All of you got till this point, tell me. I want you to feel the physics, right? How physics is used in our daily life. Till this point, everyone is getting, so kinetic energy, I'm saying that, okay, kinetic energy is not zero. It is not zero. Kinetic energy is not zero, right? Kinetic energy will be something. Yes or no? Yes or no? And we know that at this point A, if he need not to fall down, right? Let's write like this. Then I can say, okay, in this case, mg should be equal to mv square by r. Yes or no? Tell me, yes or no? Yes or no? mg should be equal to mv square by r. Yes, exactly. Okay, So mm will get cancelled, will get cancelled, right? V is equal to root gr. V is equal to root gr. Makes sense? Tell me, makes sense? Anyone have any issues? Anyone have any issue at this point? I'm talking about velocity that should be at this point A. Okay, I'll just write as V2 so that it should not fall. This velocity is not V1. This velocity is V2, right? What is V2? V2 is the velocity at point A. V2 is the velocity at point A so that, right, you don't fall. Got it, Yashash? You need not to fall down now, because if you fall down, you will break your legs, right? So I don't want you to fall down. So in order to do that, there should be force which will balance your mg. Yes or no? Think about it. Yes or no? Don't worry, this will not.
It should be 4R because when we basically equate these two formulae, we will get mg2r equals half mv square. And
Again,
when
see,
we
I'm not using this in this equation. I'm just balancing the force. Got it? I'm just balancing the force here at point A, right? This is Newton's second law. Got it? This is Newton's second law, right? At this point A, it is balancing force at point A. F at A. Got it? Right? From here I got V2 is equal to root GR. So kinetic energy at point A will be what? Tell me, kinetic energy will be half, right? M V2 square. Got it or not? Tell me, got it or not? Now you're getting the concept. Think about it. Now you're getting the concept, yes or no? Everyone? See, it might seems difficult, but you have to understand what is happening. Try to understand. Board students. No, Tapish, you are present. Don't worry. I marked you present. Step by step. Everyone got this till this point? This is a very simple concept. I just said that at point A, the kinetic energy will not be zero. Why it not be zero? Because if it will be zero, then this guy will fall down, or he might not even reach at point A. Okay, so it will be half m v2 square. What is v2? Yashash, I haven't calculated. I'll calculate it now. Wait for my calculation, right? So I'll just calculate. Now let's calculate. So I can say like this. Think about it. Then I'll use again half m v1 squared plus 0 is equal to mg into 2r plus half m v2 square. Will get cancelled, will get cancelled, right? Got it? Tell me, got it? Right? Yes? So I'll get something like this. M will get cancelled now, my bad. V1 square is equal to 2 multiply every term by 2. 4 mgr is equal to, plus half. Now v2 square, v2 is root gr. Square is, again, half is not there because we did 2 now. Sorry. So plus gr. Got it? M will also not be there. M is also cancelled. I cancelled M. M is all the sides, right? Got it? Tell me, got it? Everyone got this? Yes or no? Yes or no? So what is V1? V1 square is 5gr. So V1 is equal to root 5gr. Anyone have any issue till this point? Tell me. Try to understand and ask. Try to understand and ask. Don't worry. Try to understand and ask. I'll send the recording. Okay. So can I say, okay, the velocity should be equal to root 5 gr in order to reach at this point A. Got it, right? And what is r? R is 2. So I can say the velocity should be root 5 into 10 into 2, which is equal to, tell me, 10 meter per second. 10 meter per second. So this is the formula. This is actually a formula which you can use directly. But I hope all of you got it. Tell me. 10, yes, 10 meter per second. Yashash, got it? Tell me, got it? Step by step. Melissa, Aditya, Avya. Okay, I'll repeat step by step. I'll repeat step by step. Okay, right? I'll repeat step by step. This is very interesting, very easy concept. If you understand it, that is easy. If you don't get it, ask. Chandan, we use the same thing. Initial energy is equal to final energy. Now, step one, imagine. First of all, you have to imagine. At point B, think about it. At point B, what will be the kinetic energy? Tell me, at point B, what will be the kinetic energy? Half mv1 square, half mv1 square, makes sense? Tell me. Half mv1 square, anyone have any issue in this? Right? And what will be the potential energy? 0. Potential energy will be 0. Anyone have any issue in this? Tell me, anyone have any issue in this? Step by step. I'm explaining this again, step by step. B is initial position, na? Yes, Prahlad. B is initial position, right? Got it? Now, second, at point A, what would be the potential energy? Potential energy would be mg into 2r, mgh, height is 2r, height is this diameter, which is mg into 2r. Got it? Now, what would be the kinetic energy? Now, here is a catch. Here, you should have thought that, okay, kinetic energy would be 0, right? You might have thought that kinetic energy is 0, but that is wrong. Why kinetic energy is not 0? Tell me. Why kinetic energy is not 0? Because if kinetic energy is 0, then it means that at this point it is at rest, which means there's only one force in downward direction, which is mg, right? So this guy will fall down, yes or no? Tell me. He will break his bones, right? And I don't want him to break his bones. Just imagine if someone is doing this trick, this stunt, and he fall down and he will break his bones. That won't be good, right? So there must be one force which will balance this mg, yes or no? That is something that we have studied in chapter 2, right? Yes or no? We have studied this in chapter 2, right? And we know that if any object is moving in a circle, then it will have an outward force. If you don't know this now. If any object is moving in a circle, it will have an outward force, which is your centrifugal force, and the formula is mv square by r. mv square by r. Okay, got it? Tell me, got it? Tell me. Anyone have any doubt till this point? No? So I will balance this force, right? I will balance this force. mg is equal to mv square by r. Okay. So at this point A, okay. Yashila, there's no derivation. That is the basic formula. Okay. Okay, Yashila. Right? That's the basic formula, mv square by r. Okay. So at this point, V2 is equal to root gr. V2 is root gr. Balance it. Okay. Now, this is the velocity at point A. So kinetic energy will be what? Half mv2 square. Got it? Right? Kinetic energy will be half v2 square. For now, just remember centrifugal force is mv square by r. Right? It is intuitively derived, so don't worry about that. Okay. See, this point you understood, this point this point, right? At this point A, mg should be equal to mv square by r. Mg should be equal to centrifugal force. Yes or no? Yes or no? Prahlad, mm will get cancelled. Mm will get cancelled. Then v, right? V2 square is equal to gr. So V2 is root 2 g. Sorry, root gr. Yes or no? This you understood? Tell me. This you understood? Yes. Okay. Now, what is V2? V2 is the kinetic. V2 is the velocity at point A. So at point A, kinetic energy is not zero. It is half mv2 square. As simple as that. Got it? Now you got it. Around 6 students left the class. I'll mark them absent. Okay. Right? Got this? Tell me, got this? So I can use this now. I can use the formula now. Total energy at point B should be equal to total energy at point A, right? So at point B, we have half mv square, half mv1 square plus 0. At point B, we have mg into 2r plus half mv2 square. Put the value of v2, cancel m. M is cancelled, multiply with 2, right? So we will get v1 square is equal to 4gr plus gr, right? So v1 square is 5gr. v1 is root 5gr. That is the answer. Got it? Everyone tell me, got it? Yes or no? Got it? Clear? Okay. Everyone? So this is the formula. Prahlad, m is there, na? M is all the m will get cancelled. Will get cancelled. Okay. Got it? Right? See this? Take your time. Take your time.